Believe me, just watch.
All right, we are back on the Morning Brew with friends, with a bunch of our friends from the UNM Cancer Center. This is great. We got Dr. Cheryl, woman director of and CEO of the UNM Cancer Center, Dr. Scott Ness, the director for shared resources at the UNM Cancer Center, and Dr. Olivier Rixe, an interim associate director of clinical research. Right. And this is great. You guys just joined the new Orion program. Right. And what is that? It sounds like a big deal.
It is a really big deal. So 6 of the nation's cancer centers, including us, there are several cancer centers that are considered the best in the nation, but 6 of us have partnered. Ohio State in Columbus, Moffitt in Florida, University of Colorado, University of New Mexico. And what we're going to do is treat all of our patients the same, meaning every patient who walks into UNM Cancer Center will be consented to be followed for their lifetime.
Wow.
We'll be applying new technologies of whole genome sequencing, which Dr. Ness has developed, that sequence the genome of tumor cells to understand what mutations that person has, to really deliver what the hot topic in medicine is today, personalized medicine. Right. To give the right drug to the right patient at the right time.
And then by partnering with 5 other universities, you get a lot of great data, right?
Well, we get data, so we understand New Mexicans, Hispanics, non-Hispanic white, American Indians are affected by very different cancers with different mutations. So we bring New Mexico to the project, and the real benefit from us all working together are getting access to these new targeted drugs. So people have access to the cancer treatment they really need.
That's very cool.
It's very cool.
How does personalized medicine work into cancer treatment? You know, is it you actually sequence the person and figure out exactly what cancer they have, and then you can target it?
There's 2 ways that works. One way is that we sequence the tumor to find out exactly what kind of mutation it is, and that might indicate a specific type of drug or treatment. The other thing is that people have different variants in their other genes, the rest of the genome, and that affects how they respond to different cancer therapies or how likely it is that they get a cancer. And so both of those things are important. What the Orion program does is give us the big data that we need to decipher the very complex genome and the things that happen in tumors.
Everybody's talking about big data and how you can crunch that. See, there must be an incredible research background behind this. Is this where Olivier fits in?
I'm at the end of the process. I'm taking the information from Scott, and then we try to identify the best treatment for a very specific patient. So we have in our precision medicine now some very targeted therapies. But Scott is going to tell us which target is there for a very specific patient, and then we can deliver this very specific treatment.
That's very cool.
So this is where we are now. It has been a dream for decades. But with this network, with this information, we can now have this very, 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 very personalized medicine for each patient. Here in New Mexico, of course.
That's very cool. So that, we hear about personalized medicine, and we hear about how important this can be and how groundbreaking that can be. How far along are we really in that process of understanding personalized medicine? For years I've been hearing about the Human Genome Project. You hear about genome sequencing of every animal in the world. I mean, what does that really do for
where we are today is its application.
Okay.
So we're just now, I think, beginning to live that dream. So in leukemia, for instance, there are hundreds of different mutations. We've found unique mutations in Hispanic and American Indian children with leukemia that are different than white kids. And those mutations need a very different drug.
Wow.
And so what we're beginning...
Same disease, but it takes entirely different drugs.
Different base mutation, different drugs and treatments. Wow. So these children for years in New Mexico have not had good survival.
So
but
our
now
New Mexican kids have been getting the same drugs as somebody in
Montana
might be getting.
But they don't work.
But they don't work.
They don't work.
And how long have we known that they don't work?
Several years.
Several years.
But by sequencing the genome of those kids, we've found new mutations for which drugs exist. So the hope in all of our cancer patients is we're finding mutations in them for which there are drugs on the shelf, and the collaboration allows us to merge our data, but also get access to the drugs. There was a famous story in the New York Times last week of a woman who had leukemia, but when her genome was sequenced, the best drug for her was a drug used for melanoma. Oh. She's now in remission. Oh. So it's the promise of personalized medicine really coming to fruition, and our project brings that here to New Mexico.
That's very cool. So you guys have been traveling around to all the other hospitals around and seeing how they do things too?
Yeah, but we want our patients not to travel.
We want to treat them
We
home.
want our patient from Santa Fe, Los Cruces to get access to those treatments.
Yeah.
So we travel, but the patients won't, and the family will stay and will be very supportive. And yes, we can get access to this huge pipeline of treatments.
Yeah.
But also we have our own treatments that have been identified here at UNM Cancer Center, and we can develop those treatments in New Mexico. And then when we need to go larger and deeper, we can connect with the network and test this New Mexican treatments
All over.
worldwide.
All over.
That's very cool.
So that's both directions.
Well, I know that the Cancer Center has been working very hard on technology commercialization. And
Right.
Is this part of that movement? Or
It is
this
in a
more of
way. So many of the treatments that you may find, well, the mutations that you find that cause a particular cancer, Dr. Ness is now working on a big project because we know that colorectal cancer is exploding in Hispanic men in our state. The incidence is increasing dramatically. We don't know why. So he is sequencing tumors from men 30, 40 years ago and men today to do that comparison. So those discoveries are patentable. The new diagnostics we make from sequencing are patentable, so we've had some new patents recently. So in the last 15 years, physicians at UNM Cancer Center have had about 140 patents and 11 New Mexico startup companies.
And 11 new drugs that came out of those
Yes,
patents?
and diagnostic tools.
That's very cool.
Yeah.
That's very cool. So when you're sequencing people's DNA and you're looking at this stuff, are you finding some just crazy anomalies, or is this stuff that is, what are you really finding when you're sequencing this stuff? I'm sure it surprises with everybody.
Well, one of the most interesting things that we're working on, as Dr. Willman described, is a difference in the survival rates of different kinds of patients. For example, we found that Hispanic patients with colorectal cancer have a worse survival rate than non-Hispanic whites. So both patients have the same disease and were treated the same way, but they survive differently. And we think that that may be due to some of the genes in there that they've inherited. For example, genes that affect how well the liver removes the chemotherapy drugs from your bloodstream. It's not really a cancer gene, but it's something in the background that if you have a gene that makes you more efficient at removing the drug, then you don't get it as really an effective dose as the other person does. So if you get a little bit less dose over your chemotherapy treatment, maybe that's why you don't survive as well. So those are the kinds of secondary background things that we're looking for to try and explain the differences.
And then how do you use that data you're collecting here with the data you're getting with the 5 other hospitals? I'm sure there's just like some kind of
Huge.
giant Amazon computer like crunching these numbers.
Well, the
somewhere,
problem
right?
is the genome is so huge and complex.
It's billions of base pairs, right?
Oh, yes. 6 billion.
One of the things we're really excited about working with the Moffitt Cancer Center, which is in Tampa, Florida, is they also have a very large Hispanic population. But Hispanics here in New Mexico are genetically very different, coming from Spain originally, from European genetics, intermarriage with American Indians and white people here. Hispanics from Florida are largely from South
Cuba,
and Central
South
America, Cuba, Colombia. And
the neighboring
Caribbean,
countries.
right?
Yeah.
So their genetics are really different. So through the network, we can begin to have enough patients to do these really kinds of important comparisons. So what we're learning is a Hispanic is not a Hispanic, a white is not a white. You are uniquely who you are. And through that kind of sequencing and detailed analysis of each individual person who's sick, we tailor the right medicine.
That sounds like just super future kind of stuff, really.
Yeah, but it's going on today.
That's amazing.
Yeah.
So how long does it take to sequence a genome these days? I know that back, it took 10 years to sequence the first one, right?
Yeah, it takes a few hours to sequence a genome and then about a year to understand the results.
Wow. And but how much of that do you need to understand? Do you just need to understand a little bit of that DNA, or do you need to understand the full chunk of that DNA?
Well, at the moment, there's about 400 genes that are sequenced typically in the most comprehensive panels for cancer therapy. There's about 25,000 genes in the whole genome. So the first level of personalized medicine is looking at 50 to just a few hundred genes. We want to stretch that to look at all 25,000 genes. But even those 25,000 genes is only 2% of the genome. So then we need to find out what happens with the other 98% of the genome that controls those genes.
Wow.
And so it's a complicated problem.
That's an intense amount of information to really
huge
kind
data.
of, right, huge data. Well, we're going to be back. We'll talk more about huge data and a whole bunch more. But we got our friend Chris Duncanson from Comcast Xfinity, and he's going to come talk to us about entrepreneurship and what the folks at Comcast are doing. There's a pretty cool project they've got that maybe some of your startup companies could be in on the Morning Brew with Friends.